Hi everyone and welcome back to another lab. Today we are going to configure a layer 3 switch port as a routed port across multiple layer 3 switches. We will start by explaining what a routed switch port is and why it is important. Then we will go through the topology, the lab objectives, and finally the lab tasks. So a layer 3 switch port or a routed port is a physical interface on a layer 3 switch that is configured to act as a layer 3 interface, similar to a port on a traditional router. Unlike regular switch ports that operate at a layer 2, which is the data link layer of the OSI model, and typically used for switching frames within the same VLAN. A layer 3 switch port can handle layer 3 functions such as IP routing, and this enables the switch to perform routing tasks that would normally require a dedicated router. When a switch port is configured as a layer 3 switch port, it does not participate in layer 2 switching operations like MAC address learning or VLAN tagging. Instead, it is assigned an IP address and can be used to route traffic between different IP subnets. This is particularly useful in enterprise networks where high performance routing between VLANs is needed without the latency associated with sending traffic to a separate router. Layer 3 switch port provides a cost-effective and efficient solution for routing traffic within a campus network or between different floors of a building, eliminating the need for multiple physical routers. Not to mention, they support advanced routing protocols and features, making them suitable for complex and dynamic network environments. So regarding the lab topology, we have a couple of layer 3 switches that are connected to end devices. So we can see here PC1, which is in VLAN 10, and it is connected to switch 1. And also we have server 1 that is in VLAN 10 as well, but it is connected to switch 2. Switch 1 and Switch 2 are interconnected with each other via Gig Ethernet 01 interface, and the default gateway for PC1 is 192.168.10.1/26, and the default gateway for server 1 is the SVI 10 on Switch 2. Interface Gig Ethernet 01 on switch 1 will be configured with 10.0.0.1/30 since it is a point-to-point link, and the other side will be 10.0.0.2/30. And the objective of this lab is to show you how you can configure a switch port as routed port and provide connectivity between PC1 and server 1 even though they are in a different network. Okay, so regarding the lab tasks, the first task that we are going to tackle, we are going to configure PC1 and server 1 with the appropriate IPv4 address information. So we're going to configure IPv4 address, and then we are going to also configure the subnet mask as well as the default gateway. We will also verify our configuration by jumping into the CLI and issue the ipconfig command and reveal the data and check the IPv4 assignments. Then we're going to move to step number 2, where we are going to create VLAN 10 on both switches. And then we're going to verify our configuration. Once we've done that, we move then to step number 3, where we are going to jump into the access ports or the ports that are connected to the end hosts. So we're going to assign fast Ethernet 01 with the appropriate VLAN access, and we are going to include a link description or interface description. And also we're going to force the port to operate in access mode. Once we've done that, again, we will perform some in-flight checks, verify our configuration, and then move to step number 4. Step number 4, which is related to the SVI configuration, we are going to configure SVI on both switches, and we can get the SVI information or IPv4 address related information from the lab topology or from the lab tables. Once we've done that, we will then verify our configuration, make sure that the interface is in the up state, has been configured with the appropriate IPv4 address, etc., etc. And then once we've done that, we then move to step number 5, where we are going to configure routed port on both switches. So the interface Gig Ethernet 01 that interconnects switch 1 and switch 2, we are going to convert it from switch port to routed port. And then we are going to configure the interface with the appropriate IPv4 address. And we're going to make sure that the interface is already enabled. And then we will verify our configuration, make sure that both switches are able to ping each other and there is communication from each side. Then we move to step number 6, where we are going to enable IP routing. And once we've done that, we're going to move to subtask B, which is related to creating a default static route across both switches. And then we're going to perform some in-flight checks. And then once we've done that, we then move to step number 7. And step number 7 is the last task, where we are going to perform some connectivity tests. We're going to make sure that PC1 is able to ping the default gateway. The server is able to also ping the default gateway. And then we're going to initiate a ping connectivity test between PC1 and server 1. Okay, this is the moment where I ask you to pause the video and give this a go yourself to test your knowledge and skills. So I added the lab document in the video description so that you can download it and practice at your own pace. And I have also included a couple of packet tracer labs for you to download. You will find a pre and a post version of the lab. The pre-lab is for those who want the lab ready to go and tackle all tasks, and the post lab is for those who want the full lab solution. So enough of that, and let's dive into the lab solution. Okay, so I'm going to tackle the first task. So I'm going to go to PC1, and from there I can go to desktop, and then from here I can select IP configuration. And from there, I'll put the IP address information that is related to PC1. So I'm going to say 192.168.10.2. And the subnet mask is going to be 255.255.255.192. And the gateway is going to be 192.168.10.1. So with that being done, let's just go to command prompt, and from there, let's just issue the IP config. And you can see the information related to IPv4 address is over there, is highlighted on the screen. So that is being done. So I'm going to close this, and then I'm going to open the server 1 stencil, and I'll go to IP config or IP configuration, and under static, I will configure the appropriate IPv4 address. So it's going to be 192.168.10.91. And the subnet mask is going to be 255.255.255.192. And the default gateway is going to be 192.168.10.90. So let's just verify that quickly. So I'm going to say IP config. And you can see the information related to the interface fast Ethernet 0 is highlighted on the screen here. The IPv4 address, the subnet mask, and the default gateway. So that is the first task. Let's jump into the second task. So I'm going to go to switch 1. And then from there, I will go to global config. And then I will create VLAN 10. And I'm just going to name it VLAN 10 as well. I'm going to end this, and then I will verify the configuration by saying show VLAN brief. And you can see that the VLAN has been created. However, there is no interface or port assignment yet. Let's do the same thing on switch 2. So go back to switch 2, and here I'll go to global config. And I'm going to say VLAN 10. I'm going to name that VLAN to VLAN 10 as well. Going to end this, and then I'll say show VLAN brief. And again, we have similar output to what we saw on switch 1. Now let's move into step 3, where we are going to configure our access ports. So I will start with switch 1. So I'll go back to global config, and from there I'll be able to go to the interface mode configuration level. So I'm going to say interface fast Ethernet 0/1. First things first, I'm going to configure the description. So I'm going to say link to PC1, and also that is part of VLAN 10. I am going to make sure that the switch port is in access mode. And then I'm going to make sure that the interface is associated with the appropriate VLAN. So I'm going to say VLAN 10, and that will do. So let's just do some in-flight checks. And you can see that the interface has been assigned to the appropriate VLAN, which is VLAN 10. And we are good to go. We can also reveal the configuration by saying show run pipe section, and you can say 0/1 $, and that will give you the configuration related to fast Ethernet 01, as you can see from the screen, which is highlighted in blue. Now let's jump into switch 2 and do the same thing. So I'm going to go to switch to CLI, and I'll go to configure terminal, and from there I would say interface fast Ethernet 0/1. Set the description first, so I'm going to say link to server 1, and also that resides in VLAN 10. I'm going to say switchport mode access, switchport access VLAN 10. Do some in-flight checks quickly. And you can see that the fast Ethernet 01 is assigned to the appropriate VLAN. And now let's just do some further in-flight checks. So I'm going to say show run pipe section 0/1, and I'm going to include the $sign. And again, you can see this is the configuration for fast Ethernet 01 on switch 2. Next, let's jump into step number 4, where we are going to configure the SVI on both switches. So again, I'm going to start with switch 1. So I'll go back to switch 1, and I'll go to global config. And from here, I'm going to say interface VLAN 10. And I'm going to set the description to SVI 10. And the IP address is 192.168.10.1, and the subnet mask is 255.255.255.192. So once we've done that, let's just verify that the interface is in the up state. So we're going to say show IP interface brief, and you can see what has been highlighted on the screen is the interface that we just configured. So interface VLAN 10 assigned with this appropriate IPv4 address, and right now is in the up state. If we say show run pipe section, and let's say LAN 10 $, you will be able to reveal the running config for the interface in question. Let's do the same thing on switch 2. And you can see that by verifying our configuration, you can see that the interface is in the up state and is configured with the appropriate IPv4 address as well. And let's reveal the current config for that interface as well. So I'm going to say show run pipe section LAN 10 $, and this is the current config for interface VLAN 10. If you want to do further checks, you can say show interface VLAN 10. And here you can see that the interface is in the up state. This is the MAC address. This is the description. And this is the network address or the IP address that is related to the network information. And the rest of the information is related to the interface statistics. And with that being done, we can then move to step number 5, where we are going to configure the interfaces that interconnect switch 1 and switch 2. So I'm going to go back to switch 1 again. And I'll go to global config. And from here, I can say interface gig Ethernet 0/1. And I'm going to set the description first So I'll say description and then link to switch 2. And to enable the rooted port, we would need to negate the switch port command. So we're going to say no and then switch port. That command will disable the switch port mechanism and it will enable the rooted port. So we're going to hit enter and you can see that the link has been flapped. It went down and then it went back up again. And from that point, we can then configure the interface as we are configuring on a router. So I can say IP address 10.0.0.1 and that is going to be 255.255.255.252. And just for the sake of it, I'm going to say no shot and then I will hit end. And now let's just do some verification. So I'm going to say show IP interface brief. And you can see that we've configured this interface with this IPv4 address there. And right now is in the up state. So layer 1 and layer 2 are good to go. Let's jump into switch 2 and do the same thing. So I'm going to go back to global config. And from there, I'm going to say interface gig ethernet 0/1, set the description, link to switch 1, and then negate the switch port command. So I'm going to say no switch port, and that will flap the interface. And now we should be able to issue the IP address command. So I'm going to say 10.0.0.2, and the subnet mask is 255.255.255.252. And we're going to say no shot. Next, we are going to end this to get out of the global config mode and go to user privilege mode. And from there, we will be able then to do some in-flight checks. So I'm going to say show IP interface brief. And here you can see that gig ethernet 01 is already configured with this IPv4 address and right now is in the up state. Now let's perform some further in-flight checks where we're going to ping the IPv4 address of switch 1 gig ethernet 01 interface. So I'm going to say ping 10.0.0.1. And you can see that we have successful ping. If I ping that again, we get 100% success. And again, you lose the first ICMP echo message due to ARP, but the second time we get 100% success. Next, we can move to step number 6, where we are going to configure IP routing on both switches, and then we are going to configure a static route on both switches as well. So I'm going to go back to switch 1. And on switch 1, if I issue the show IP route, you will see there is no table right now. And that's because IP routing has not been enabled. So I'm going to go and do that right now. So I'm going to say configure terminal, and then from there, I would say IP routing. Once you initiated this command, we then should be able to reveal the routing table. So if I say show IP route, you can see that I've got 2 networks that are connected to switch 1. The first network, which is 10.0.0.0/30, and then the next, or the second network is 192.168.10.0/26. So next, let's do the same thing on switch 2. So again, if I issue show IP route, we get similar output to what we saw on switch 1. And let's enable IP routing on the switch. So I'm going to say configure terminal, and from here I should be able to say IP routing. End this, and let's just issue the show IP routing. And we get similar output to what we saw again on switch 1. Next, we can move to the next subtask, which is to create a default static route across both switches. And there are two methods that we can do this. The first one, we can create a default static route to direct all unknown destination to the next hop by using a specific command, which is the IP route 0.0.0.0, and then the subnet mask 0.0.0.0, and then the next hop, which on switch 1 would be 10.0.0.2, which is pointing to the switch 2 interface. And we're going to do the same thing on switch 2. Alternatively, we can specify certain traffic to be routed from one network to another. So I have included these two solutions in my playbook. Feel free to experiment both solutions. But please be aware that if you are going to be more specific about the IP route command, then you are not actually configuring a default route. So with that being said, I'm gonna use the first method, which is the default static route, and I'm gonna implement that now. So I will go back to switch 1, and from there I'll go to configure terminal, and from here I would say IP route. And if you question mark that, so this will reveal the content sensitive help for that specific command. And as you can see, the options that we can use is we need to set the destination prefix. So in that case, or in my case, I would say 0.0.0.0. And then if we question mark that again, we then prompted with the destination prefix mask. Again, we are going to include any destination subnet mask. So we're going to say 0.0.0.0. And then if we question mark that again, we will then need to set the next hop address. And at that point, we can then configure the forwarding router's address, which is going to be 10.0.0.2. So if we question mark that, we can then set a particular distance metric. We will discuss this at a later stage. But right now, for the sake of just configuring a default static route, we are just going to accept this command, and then let's just perform some in-flight checks. So I'm going to say show IP route, and you can see that there is a static route has been installed or populated in the routing table, but also you can see or read this message where it tells you here that the gateway of last resort is 10.0.0.2 to any unknown destination or any unknown networks. Okay, so next we are going to do the same thing on switch 2. So I'll go back to switch 2 and I'll say configure terminal, and from here I can then issue IP route 0.0.0.0, and the subnet mask is 0.0.0.0, and the next hop address is going to be 10.0.0.1. End this, and then I would say show IP route. And similar to what we saw on switch 1, we can see the default gateway, or this is the static route that we just implemented or configured. And here it tells you explicitly that last resort is 10.0.0.1. So if you want to do some further in-flight checks, we can reveal the configuration, for example, by issuing the command show running pipe section route, and you'll be able to see that we have configured this line, and that line is in the running config as we speak. At this point, we have completed all tasks related to setting up the lab. Now we can move to step number 7, where we are going to perform some test connectivity between PC1 and server 1. So I'm going to go back to my topology, and I'll go to PC1, and then from there I'll go to command prompt, and my initial test will be to the default gateway. So I'm going to say 192 or ping 192.168.10.1. And you can see that I am able to ping SVI 10 on switch 1. And let's ping server 1 IPv4 address. And as you can see, we have managed to successfully ping server 1 with no issues. So that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success, so stay curious, stay inspired, and until next time, peace.